Hi, my name is Jennifer, and I'm going to show you how to divide polynomials using a method called the synthetic division. So grab a pencil and some paper and work through this problem with me. Let's take the example x squared minus 5x plus 6 divided by x minus 2. Synthetic division is a faster way to divide polynomials when compared to the long division method. However, you can only use this method if you have x minus a number or x plus a number as your divisor. And since we have an x minus 2 as our divisor, we can go ahead and start the synthetic division process. The first thing you'll do is we're going to draw what I call a corner on the edge of your paper. In this corner, we are going to put the opposite number found in our divisor. We have the constant negative 2 in the bottom of our fraction. So we're going to put positive 2 in our corner. The next step is to take each of the coefficients in the top fraction of the fraction, and we're going to list them in this horizontal line next to our corner. Our first coefficient is a positive 1, then we have a negative 5, and we have a positive 6. Next, I want you to skip a space and then draw a straight line. Now we have the problem set up and we're ready to actually work through the problem. Our first step in synthetic division is to drop the first coefficient down to the answer line. Next, we're going to take the number in our corner, and we're going to multiply it by this 1 and put the answer directly underneath negative 5. 2 times 1 is 2. Next, we are going to add negative 5 plus 2, and we're going to put the answer directly underneath it. Negative 5 plus 2 is a negative 3. Then the process begins again. We're going to go back up to our corner number. We're going to multiply 2 times negative 3 and put the answer underneath this positive 6. 2 times negative 3 is negative 6. And then we're going to add those two numbers together. 6 plus negative 6 is 0. Now our answer is almost complete. We have the coefficients to our answer, but now we need to put in our variables. When working with synthetic division, the very last number on the answer line is considered our remainder. So this problem has a remainder of 0. The 1 and negative 3 are the coefficients to our answer. Because this was a division problem, we're going to start with the term 1 lower than the original trinomial. Our trinomial, the highest degree, was x squared, so our answer is going to be 1 term lower than an x squared. So we are going to make this first coefficient our x term, and the negative 3 is going to be our constant. The final answer to this division problem is x minus 3 with a remainder of 0. Okay, let's try another example using the synthetic division. we have x cubed minus 4x squared minus 9 minus 7, all divided by x minus 2. We're going to first draw our corner, and we'll put positive 2 in the corner. Next, we're going to list out the coefficients straight across in order. And we have the coefficient of 1, then we have a negative 4, negative 9, and a negative 7. I want you to skip a space and then draw a straight line. Now that we have the problem set up, we're ready to start solving. The first step in synthetic division is to drop the first coefficient down to the answer line. Next, we're going to multiply 2 times 1, and we're going to put the answer directly underneath negative 4. The next step is to add negative 4 plus 2, which is a negative 2. Then we're going to multiply negative 2 times our corner number. 2 times negative 2 is negative 4. And then we'll add negative 9 plus negative 4, which is a negative 13. Then it continues. We're going to multiply negative 13 times the corner number, which is negative 26. Then we'll add negative 7 plus negative 26 to get negative 33. Okay, pause right there. Let me just make sure this math. I've done this problem a million times, but I don't remember this answer. Let me just make sure I did it. Negative 2, 4, that is 13, that is 26, right? 7, and that's negative 33. I don't have my answers written down, but I think that's right. Oh, you know what? Darn it, Jen. This was supposed to be a plus 9 up here. Oh, no. But I think it's okay. I think I can still work it. I just have that's why I have such a big remainder, but that's okay.
Take a little bit off of the negative 4. Just
oh. Okay. I can still finish it up.
Okay.
I was just thinking, I mean, you've done these problems for so long, I'm like, 33 is not the remainder, but
you looked at it for like a long time.
I know. Okay. All right. So can I just recompose myself and finish the problem? Okay. Okay. Now that we have our list of coefficients at the bottom, we need to assign each coefficient back to an x term. When doing synthetic division, the last term is always our remainder. So in this problem, we have a remainder of negative 33. Next, we need to take the coefficients 1, negative 2, and negative 13 and assign an x term to them. Now, since our original problem, the highest degree was an x cubed, our answer will start 1 less than the x cubed, which is the x squared term. So we will assign the coefficient of 1 to be our x squared term. The coefficient negative 2 will be our x term, and the negative 13 will be our constant, And of course, the negative 33 is our remainder. So here's how you write your final answer. Our final answer is x squared minus 2x minus 13. And remember how we write our remainders from the long division video. We're going to put the remainder minus 33 in the numerator over our original divisor, which is x minus 2. So even though it makes the answer look a little funny, our final answer is x squared minus 2x minus 13 minus 33 over x minus 2. Okay, let's try one more example using the synthetic division. This example is y cubed minus 27 divided by y minus 3. Now I want you to get into the habit of noticing if our top polynomial is in descending order. As you can see, this example, the first term is a cubed, the second term is a constant. So we're missing the squared term and then the y term. Before we can do synthetic division, we need to put in placeholders so that the method works correctly. Our first step, we'll put our positive 3 in the corner. Remember, it's always opposite of the constant in the bottom of the fraction. Next, we'll be careful to put out our coefficients horizontally across, making sure that we include our placeholders. The coefficient of y cubed is 1. We do not have a y squared term, but we need to put a 0 placeholder. We do not have a y term, so we'll need another placeholder. And then we have a constant of negative 27. I want you to leave yourself a space and then draw a straight line. Now we have the problem all set up and we're ready to start. The first step in synthetic division is to drop the first coefficient down to the answer line. Next, we'll take that answer, multiply it by our corner number, and put the answer directly underneath the first 0. 3 times 1 is 3. Then we'll add 0 plus 3 to get 3. And we'll multiply that answer times the corner number to get 9. We'll add 0 plus 9, which gives us 9. We'll do it one more time. Multiply 9 times 3 to get positive 27. Negative 27 plus positive 27 is 0. Now we have a list of numbers which will be our coefficients for our answer. The last number will always be our remainder. So in this problem, we have a remainder of 0. Next, we need to assign the coefficients 1, 3, and 9 back to terms. Now remember, our original problem, the highest degree was a cubed, so we need to start with the term 1 less than y cubed. So the 1 will assign y squared, the 3 will be our y term, and the positive 9 will be our constant. So here's what the final answer will look like. We have y squared, then we have a positive 3y, and a positive 9, with the remainder of 0, which we don't have to include. Now, if you still have questions about this topic, please contact your professor, or stop by the Math Tutoring Lab, or watch this video again.